Here are several magnets that I picked up either in various places around the physics department or a couple of them from my house. So I don't know where to start here, but here is a fairly heavy-duty horseshoe magnet that we have in some of the physics labs here. And so there's a north pole on one end of the horseshoe and then a south pole on the other end of that horseshoe. I have a couple of disc magnets here that of various sizes. Some neodymium magnets, which are actually fairly strong, and we keep them in these little plastic cases because when they're together, they're incredibly difficult to pry apart if you don't have a little bit of separation between them. And then raided the kids' toy supply. Actually, I don't know. These might have been mine. And we have some magnetiles, which some of you may have played around with before, but they have tiny little magnets in there, and then you can make various arrangements out of them as the magnets stick together. And then a couple of magnets that go on my refrigerator that I think actually demonstrate an interesting property. So the exploration asked, can you get two magnets to attract or repel each other? So I'm going to move several of my magnets out of the way so they don't interfere with this and just leave myself with a couple of these disc magnets. And I would suspect, yes, indeed, I can get them to attract, but if you flip one of them over, they actually now repel one another and they're pushing away, and I'd have to do work to get it there. And if you just put it down on the paper and let it go, the one's going to flip around and then make itself so it aligns and attracts with the other one. And yeah, that's the attractive one. So sometimes you can, when they're in the repelling, you can get one to push away from the other. In these disc magnets like this, the poles are largely on the flat ends, but if you have them oriented opposite to each other, they will repel. These neodymium magnets are even stronger, so I would assume that we get an even stronger reaction there. And then if we flip it over so it attracts, yeah. And of course, they don't have to be matching kinds of magnets. We should be able to get an interaction between our neodymium magnet and our bar magnet. Hopefully I can pry that off at some point. And then the last thing I wanted to show you in these magnet-magnet interactions was these. If you have some refrigerator magnets that are flat, very likely you can do it with these. So these each have a strip of magnet on the back there, and in fact, I can stick them together and they will stick. I think, well, they stick in that orientation too. It kind of depends on where they are and how I have arranged them relative to each other. But in any of these magnets, the magnetic poles actually occur in stripes on these magnets. And so if I get them in an attracting orientation, I don't know what's the best way to do it. Maybe I'll just do it opposite, like here. Here they're attracting, but then if I try to push them this way, they jump to like another zone of attracting, and in between is actually a zone where they repel. So you can slide one along the other and get this snapping sound because they're jumping from attractive line up to attractive line up to attractive line up and skipping the ones in between where those two magnets actually repel. And these are fairly strong magnets. If you get some thinner, some of those rectangular picture magnets, you get the same effect, but you don't get as large of a force on those.